Mercury is literally shriveling like a forgotten souffle in the cosmic oven. That single image might sound dramatic, but it captures the surprising truth scientists have uncovered. The Sun's nearest planetary neighbor has been steadily shrinking for 4.5 billion years. And here's where it gets controversial. Some experts still argue about whether the planet is merely cooling off or actively dying in a way we don't yet understand. So, how much smaller has Mercury become? Picture a piping hot chocolate chip cookie fresh from the oven. As it cools, the surface cracks, the edges curl, and the whole thing contracts. Mercury has been doing the same thing on a planetary scale. As its once molten interior loses heat, the entire globe contracts, forcing the brittle crust to crumple. The result is a spiderweb of thrust faults, massive cliffs where one block of rock has slid over another, scarring the planet's face like the cracked top of an over-baked cheesecake. For decades, planetary geologists tried to measure this shrinkage by adding up the length and height of every cliff they could see. The problem? The answer you get depends on how many faults you decide to count. Early studies threw out wildly different numbers, anywhere from a modest 1 kilometer to a jaw-dropping 7 kilometers shaved off Mercury's original radius. That's like arguing whether a basketball has deflated by the thickness of a coin or by the width of your palm. Clearly, the range is too wide to trust. Enter James Lovelace and Christian Klimczak. Instead of counting every wrinkle, they flip the script. Their new technique zeroes in on the single largest fault in any given dataset, measures how much contraction that one scar accommodates, and then scales that value to the entire planet. Think of it as judging how much a sweater has shrunk by looking at the tightest seam rather than measuring every loose thread. To prove their method is robust, the duo tested it on 3 separate fault catalogs, a monster list of 5,934 scarps, a medium-sized set of 653, and a deliberately tiny sample of just 100. Remarkably, all 3 returned the same ballpark figure. Mercury's radius has contracted by roughly 2 to 3.5 kilometers due to faulting alone. When they folded in additional contraction that might come from deeper, non-faulting processes, such as the slow crystallization of a partially molten core, the total estimated shrinkage climbed to between 2.7 and 5.6 kilometers. But here's the part most people miss. If this new method is right, earlier high-end estimates, the 7-kilometer crowd, may have been double-counting deformation or overestimating cliff heights. That's not just a bookkeeping error. It changes how we model Mercury's long-term thermal history. A smaller contraction implies the planet cooled more slowly than previously thought, which in turn affects guesses about how much sulfur or potassium still lingers in its core. And this is where opinions diverge. Some researchers argue that if Mercury's cooling has been gentler, perhaps its magnetic field, generated by a molten outer core, could persist longer than expected. Others counter that a slower cooldown might mean the core is already solidifying, hastening the demise of that magnetic shield. Which camp do you side with? The same mathematical toolkit could soon be aimed at Mars, the Moon, or even icy moons like Europa, each of which bears its own collection of faults. Imagine rewriting the thermal biographies of entire worlds simply by remeasuring their wrinkles. The study, published in AGU Advances https://2025 AVO1715, is already sparking lively debate at conferences and on social media. Some planetary scientists praise the elegant simplicity of the new approach. Others worry that ignoring smaller faults might hide important regional variations. Where do you stand? Drop your take in the comments. Do you trust the one big fault shortcut, or should we keep counting every crack in the crust? Breaking space news, upcoming rocket launches, and sky-watching alerts. Stay tuned for more. This article first appeared in EOS. https://eos.org. Research Spotlight / How much has Mercury shrunk? For deeper discussion, jump into our space forums, https://forums.space.com, or email us at community@space.com with tips, corrections, or hot takes. About the author. Sarah Stanley is a freelance science writer with roots in environmental microbiology. Her bylines include PLOS, Stanford Medicine, and Cancer Commons. But her heart, or at least her telescope, belongs to the planets.